Today we're going to talk about slope and rate of change. Just like some other things I've told you will stay with you throughout your math time, this will also. So slope and rate of change are something you'll deal with all throughout high school in different classes. Algebra 2, pre-calculus, calculus, all those kinds of things. So first of all, I want to let you know that slope and rate of change mean the same thing. Now, most of the time they'll use rate of change when we're talking about actual objects or things that are changing together. Like perhaps if we're talking about, as time goes by, how is the population changing? Or as the concession stand sells more pretzels, what's the profit they're making? So they tend to use rate of change more often in real world stuff and with word problems, but it means the same thing as slope. So what is slope? Slope is a measure of the steepness of a line. So if you've ever been snow skiing, they call those slopes because in snow skiing you're always going downhill. But the reason they have a ski lift to help you go up is because it'd be pretty hard to travel uphill on skis. You may have even noticed sometimes in the interstate where it has a warning for trucks because the descent is pretty steep for them. Due to their big size, they need to be aware to go a little bit more slowly. Another way it can be defined is how quickly and in what direction is y changing in relation to x. So I add this second one because this first definition will make really good sense when we're looking at graphs. But when we're dealing with equations or we're dealing with ordered pairs or tables, I think this second definition will be a little more informative. So there are 4 different types of slope. The first is positive. A positive slope is one that moves uphill as you look from left to right. So if you think about if you were a person right here and you were told to travel to the right, you'd have to go uphill. So that's a positive slope. So there's also a negative slope. This is when you're going downhill. Sorry, that wasn't a super straight line, but you get the picture. Again, you always think about it as you're moving from left to right. If you're on the left part of this line and told to travel to the right, you'd be going downhill. In skiing, I'm guessing this is beyond black diamond or double black diamond level. That's crazy steep. But there can also be a slope of 0. And that's when the line is horizontal. Because there is no, I'm not saying that. The slope is 0 here because it's not going uphill, it's not going downhill, it's just staying flat. Now the last is called undefined. And that's when we have a vertical line. So if you just have a sheer cliff, it's considered an undefined slope because we can't really say how far it's going up at what speed because since the x isn't changing, we just call it undefined. So to try to help you see a difference between these two, here, if you look at every point we'd have in this line, the y value would be 2. So the y isn't changing at all. The y is not changing at all. So that's why we say the slope is 0, because there's no change in the y as we go across this. However, this one's called undefined because y is constantly changing, but it's doing it all on the same x value. And it doesn't matter whether it's a vertical line at -2, at +3, at 0, any vertical line that's going to be true. The y's are changing all over the place. Every point on here has a different y value, but they all have the same x value. So it's changing essentially infinitely in relation to x, because x isn't changing. So there's 3 different ways we'll have to learn to find a slope. One is finding slope from a graph. To do that, pick 2 points on the line. Connect them by making a triangle. I'll show you this in just a second. Oops, triangle. I'll show you this in just a second on this graph right here. And then you'll count the rise and the run. In other words, the rise is really saying how far up or down do we have to go first? That's the question. And then how far over to the right do we have to go to get from this dot to this dot? And slope is always rise over run. So this isn't a slash, this is division. The slope is often a fraction, and you always put the change in the y, which is the rise, over the run. So if I look right here, I need to go up and then over. So you don't have to draw this triangle if you don't want to, but that's what they're talking about, just to help you see, okay, if I start here, I have to go up 1, 2, so my rise is 2. My run, as I start from here, is 1, 2, 3. So the slope of this line is 2/3. Because to get from one point that's actually in whole numbers to another point that's actually in whole numbers, you have to go up 1, 2, and over 1, 2, 3. And you know what? I'm going to go ahead and do the examples of this that are on the back, because it occurs to me it's probably easier to just practice all one kind before we move on to the next kind. So flip over to the back of the page, and we'll look at number 2. So they've got the points marked for us. Most of the time I will have points marked for you, but if not, you just need to look at ones that actually hit where lines cross. So we know this is going to be whole numbers because it's at a place where lines cross. Whereas this would be tough to do because, yeah, I know it's x equals -2, but it's hard to know if that's 0.5 or 0.6 or 0.55, so that wouldn't be helpful. So the reason I marked these two is because they're at a place where we have whole numbers. So always start at the point on the left, and we see we need to go up 1 and over 1, 2, 3. So up 1 and over 1, 2, 3. So this is a slope of 1/3. So we go up 1 over 3. And M is the letter that is used in math to represent slope. I don't know why they didn't use S. Seems like it makes sense, but M is the letter used for slope. You can also just write the word slope equals 1/3. Okay, now let's look at this one. Now only 1 point's marked here, but if you look, all of these are hitting whole numbers. So I'll just do this one right here. So I start at the point on the left, then I need to go down 1. So when you go down, you make it a negative number. So I had to go down 1 and over 1. So down 1, -1, to the right 1 is +1. So you can leave that as a fraction, but honestly, it'd be better to go and say, okay, -1 divided by 1 is -1. So this answer is not wrong, but it's better just go ahead when it's over 1 and just make it a whole number. So when you're going down, it's negative. When you're going up, it's positive. And we'll almost always be going to the right, which is positive. But you can do it by going backwards as well, because if you look, if we'd started at this point, I'm going down 1, which is -1, and then to the left 3, which is -3. Because down and left are negatives, up and right are positives. So -1 divided by -3, when a negative is divided by a negative, the negatives cancel and you get a positive. So you can get the correct answer really starting at either point and going either way. I just think it's simpler to have a consistent method and start at the one on the left. That way you only have to think about up being positive, down being negative. then you're just always going right, which makes the denominator positive. So that's how to find the slope on a graph. Now next, finding the slope on a table. Count the change in the y values and change in x values. Then you'll write those changes into a fraction. And just like rise over run, you'll do the change in y over the change in x. So as we look right here, it should be consistent all the way through. Go here to here, we're saying plus 2. Here to here, we're saying plus 2. Here to here, we're saying plus 2. Here we're doing plus 5, plus 5, plus 5. So the change in the y's is 5 each time. The change in the x is 2 each time. So our slope this time is 5/2. So this relates more to that second definition I gave you. How quickly and in what direction, meaning positive or negative, is y changing in relation to x? So every time x goes up by 2, y goes up by 5. So this is showing the relationship between the change in y and the change in x. So let's look at the two examples on the back that do this. So find the slope. So I'll just do the y's first since it goes on top. Notice this time we're going down. So it's going down 2, down 2, down 2. And it keeps going. So on top, I'll put a negative 2 because I'm going down 2. Now the x is going up 4, up 4, up 4. So I put a positive 4 on the bottom. And when possible, you do need to reduce the fraction. So this, you will lose a point for leaving it this way. But we reduce this and say the slope is negative 1/2. Okay, then we look at the same one right here. It doesn't matter if you figure out the x to y first, just as long as you remember the y goes on top, the x goes on the bottom. But I'll just do the y's first. So that's going up 3, up 3, up 3. This one though is going down 1, down 1, down 1. So I would say that the slope is a positive 3 over negative 1. And positive 3 divided by negative 1 is negative 3. So the slope for those is negative 3. Now, before I do the last type with ordered pairs, I want to go ahead and fill in this up here for you. I already told you slope and rate of change are the same thing. This kind of says what I already said, but let's write it down. So it says, what is rate of change? Rate of change is slope in the real world. Because there really are lots of ways statisticians, researchers, and all those things find linear equations that represent what goes on in business, biology, chemistry, mechanical things, all that kind of stuff. But truthfully, we often just give you numbers to compute this stuff. But the rate of change is when it really is representing something that's real, not just an academic exercise. So let's go to our last point. Finding slope from 2 points, meaning from 2 ordered pairs. So this is the formula you need to remember for life. So substitute, or at least until you graduate high school and or college. Substitute the coordinates, substitute the coordinates into the slope formula, which I'll write in just a moment. It's not a difficult one. So we have 2 points. So x1 and y1. and we have x2 and y2. When we write numbers down below, that's called a subscript, and that's simply a way to identify the number. So if I'd written a 2 like up here, you know that was an exponent. It's called a superscript. It's an exponent. That's actually an operation. These aren't operations. This is just saying this is x from our first point. This is y from our first point. This is x from our second point. This is y from our second point. So the formula is y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. Because you're finding the difference, subtraction is difference. You're finding the difference in the y's divided by the difference in the x's. So here's an example, and then we will try the two on the back. Let's say we were given the points -4, +3, and -6, +5. You don't have to label them like I'm about to every time you do this, but I think it's helpful as we're learning to make sure we know what's what. So this is our first point. I'm only calling it the first point because it's listed first. This is the x value, so it's x1. This is the y value, so it's y1. This is the x value, so it's x2 because it's from the second point. This is a y value, it's y2 because it's from that point. So we do y2, which is 5, minus y1, which is 3, over x2, which is -6, minus -4, because that's our first x. 5 minus 3 is 2. Minus a negative changes to plus a positive. -6 plus 4 is -2. And 2 divided by 2 is -1. So the slope of the line that would pass between these 2 points is -1. So let's wrap up by practicing the last 2 on the back using the slope formula. So this is x1, y1, x2, y2. And we do y2, 4, minus y1, 8, over x2, 2, minus x1, -5. So y2 minus y1 over x2 minus x1. 4 minus 8 is -4. Minus a negative changes to plus a positive. 2 plus 5 is 7. And that won't reduce. We can't divide -4 by 7, so our answer is -4/7. That is the slope of the line that would pass through those 2 points. Our last 2. Find the slope of the line that passes through 0, 2, and 2, 12. So we have our x in the first point and our y in the first point, our x in the second point and our y in the second point. So y2 minus y1 will be 12 minus 2. x2 minus x1 will be 2 minus 0. 12 minus 2 is 10. 2 minus 0 is 2. And 10 divided by 2 is 5. So I hope you'll see these are not very difficult, but it is 3 different ways we go about finding the slope. So what's really important is for you to commit to your memory that when you're doing a graph, you need to start at the point on the left, count how many points up or down, then how many points over. With a table, you figure out how much the y is changing each time, put that on top. Find out how much the x is changing each time, put that on the bottom. And with ordered pairs, you've got to remember the slope formula. y2 minus y1 over x2 minus x1.